Question 13. Identify the image of point A, negative 6, negative 9 when A is reflected across the y equals line, y equals x line. Okay, so what happens when y equals x? That means we just want to switch our coordinates around, so my new A will be at negative 9, negative 6. Okay, determine the coordinates of the image of the point negative 6, negative 2 is reflected across the line x equals negative 4. Alright, so my new P, if it's reflected across x equals negative 4, just a little hint here. When you have horizontal or vertical lines, they're actually really easy. In this case, it's a vertical line at negative 4. The original point is at negative 2, negative 6. So it's going to go across here to 2 more units past negative 4, so that's going to be negative 6. On the x, oh wait, I got that there. Alright, working with vertical lines or horizontal lines is real easy. Think of it this way. Let's say you have 2 points here. Here's my x equals 4, negative 4 line. Okay, negative 6, negative 2, so negative 6, let's say this is negative 6, negative 2. Okay, that means that this coordinate will be at negative 2 still. Negative 6 is 2 units away, going back 2 more units, that's going to be negative 2, so my answer will be at negative 2, negative 2. It's just a matter of counting. Use mapping notation to represent a 90-degree clockwise rotation about the origin of point xy. And that's actually another question that we've already answered from earlier. Xy is mapped onto negative yx for that notation. Okay, question number 16. Draw the image of triangle RST after a rotation of 100 degrees about the origin. So R is actually going to be right here. Here's my new R. S is going to go, let's see, right here is my new S. And T will be right here. So this is what your new triangle should look like. Alright, draw the reflection of the figure across this line. So we're just going to kind of estimate here, since we don't have any coordinates. Just a little rough sketch here what your shape should look like. So something like that should be sufficient. Question 18. The figure above the line y equals negative 1 is reflected across the line y equals negative 1, and then reflected across the line y equals negative 5. Determine the slope and magnitude of the equivalent translation vector. Alright, question 18. Don't worry about this. We haven't covered magnitude or vector, so we're not going to worry about this too much. So just ignore that. Don't worry about it. We'll move on to the next question. Alright, question 19. Graph the polygon and its reflection in the given axis. So, y-axis, that means we're reflected across this y-axis line. So just kind of having a little rough sketch here. Negative 5, 0. So negative 5, 0. Negative 3, 3. 0, 0. Negative 3, 3. So it kind of looks like this. So J. That's L. K and M. And typically, it's reflecting across the x-axis, so it should look like this. Kind of rough sketching it a little bit. If you have some graph paper, it should look a lot nicer. And that would be what looks like a little bow tie looking shape. Alright, question 20. Identify and describe the transformation. Alright, since we're adding and subtracting, that means this is straight up translation. So we're going to translate 4 units right. That's what the plus 4 right here means. And then minus 6 means that we're going to translate 6 units down. Okay, question 21. Decide whether the transformation from figure A to figure B is a translation, reflection, or rotation. Alright, so seeing how figure A to figure B Looks like your object is rotating around, so this is a rotation. 22. Decide if this transformation from figure A to figure B is a translation, reflection, or rotation. Since it looks like this is a mirror image or a copy of itself kind of reflecting over, this is a reflection. Question 23. Is figure A rotation of figure B? If so, give the angle and direction of rotation. Actually, this looks like more of a reflection, so my answer would be no. This is not a rotation. It is a reflection. 24. Determine whether the figure has a line of symmetry. If possible, identify the number of lines of symmetry. Why, yes it does. We can divide this into two equal parts here. We can cut it right here into two more equal parts. We can cut it like this into two equal parts. And we can cut it like this into two equal parts. We can even cut it like this into some more equal parts. So it looks like this one has many lines of symmetry. Alright, so how many lines did I just draw? Let's count. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to count there because that was my first line. Everything else was repeating after that. So 8 lines of symmetry. And that's all the question asks for. Alright, 25. Draw the lines of symmetry. Describe the rotational symmetry for the rhombus. Alright, so we have 1, 2 lines of symmetry. So that's simply all we need to say. It has a 180-degree rotational symmetry, if you would even add that. Alright, moving on. Question 26. For a regular hexagon, draw all possible lines across which you can reflect the hexagon onto itself. Alright, so there's obviously one here. I can draw one here, one here, one here, one here. So kind of like the octagon, there's actually 6 lines of symmetry. 1, 2, 3, 4, 5, and 6. '27.